then subnet mask, different things. Fine. So today I'll cover this, which is networking protocols, which is needed for network security. So when it comes to network security, knowledge of network protocols is much needed. And when it is network protocols, number one protocol, what we'll be discussing is about TCP and UDP. So TCP and UDP, TCP is what? Transmission Control Protocol. TCP is Transmission Control Protocol. UDP is User Datagram Protocol. Now, your interview questions will be like this. Probably when you go for an interview, they might ask you questions like this. What is TCP and what is UDP? TCP and UDP. And for the interviewer who is sitting in front of you, his mind will be very blank like this. Whatever you're going to answer, he is going to picturize. He's going to picturize based on your answers and keywords. Now, if I ask you what is TCP, what will be your answer? What is TCP? Yes. Okay. I'm asking what is TCP in plain text. There are two things. One is what is TCP and what happens in TCP. What is the process of TCP? So we have different things in that. So when someone is asking you, what do you mean by TCP? He is asking for the first one. So he's asking a plain text answer of what TCP is. What will you answer? That is a process of TCP. TCP is connection oriented. TCP has no data loss. These are all different processes of TCP. Apart from that, stateful protocol is again the process of TCP, what it does. But in network, okay, he says network packets. Network. He says network packets. What was my question? My question was, what is TCP? What is TCP? And he answered network packets. Network packets. Whose network packets? Which network packet? Where did this network packet come from? So based on your answers, he's going to draw something like this. He's going to picturize. So whatever you're going to answer, just picturize in your mind like this, in a blank sheet. Whenever you're going to answer something like this, I'll tell you what TCP is. When he asks what is TCP, you can start from the very basics of computer. That is, computer communication happens in the form of packets. Computer communication. Computer communication between two computing devices. That can be a computer, that can be a server, that can be a CCTV camera, it can be any device, firewall, whatever it is. We'll generally name it as computing devices. Fine. So we have all these computing devices. Two computing devices, in case they want to communicate with each other. This communication happens in the form of packets. That is the base for computer communication. Any sort of communication. From here, you make a Skype call to this person, that goes in the form of packets. Packet level. He replies back. He's sending you a mail, that comes in the form of packet. You are chatting with someone, that goes in the form of packet. Any form of communication that happens between computers, it happens in the form of packets. This is the base for hacking. This is the base for forensics, pen testing, whatever you have. Computer communication happens in the form of packet, and this packet is like a courier packet. It's like a courier packet which has from address and to address. From which device to do which device. Yes. I'll tell you a very simple example. In case from this computer, if I'm opening a browser and I'm typing here google.com. Google.com. This packet, it goes to the Google server, and for me, Google page opens just like this. Just like this. When I type google.com, enter, Google page opens. Now, can anyone tell me how many packets were transmitted to and fro between my computer and Google server? Develop packets. Roughly around 300 plus packets would have been transmitted. 300 packets just for typing google.com and this page opens. So any form of communication that happens in the form of packets, that is a basic. Now, after explaining this, so first you explained the basics of computer communication, which happens in the form of packets. Now, after saying this, you can tell him, so two computers, in case they want to communicate with each other, now we understood it happens in the form of packets, perfectly fine. And this packet communication can happen in different modes. These packets can be sent from the sender to the receiver in different modes. Either he can send it through TCP or he can send it to UDP. So when someone is asking what is TCP and UDP, in very simple terms, you can tell them if they are communication protocols. They are communication protocols with which two computing devices communicate with each other. Two computing devices. These devices can be anything. These can be computers, these can be servers, routers, firewall, whatever it is. They're all computing devices. Two computing devices, they want to communicate with each other. Yes, they can either communicate through TCP or UDP. So they are communication protocols with which two computing devices can transmit with each other. They are communication protocols. Protocols with which two computing devices, say, can be a computer, it can be a server, can be a CCTV camera, it can be a firewall, it can be anything, can communicate with each other. So next time when someone asks you what is TCP, please don't answer them. It is connection oriented protocol, stateful protocol. No, it is not that. Yes, it is that. But when they're asking what is TCP, first explain them about the packet communication. Any computing devices, they want to speak with each other. It happens in the form of packets. And these packets can be sent from one device to another device, either in the form of TCP or in the form of UDP. Now, coming back here, now assuming, say, this to be the sender, this to be the receiver. They are inside the network, outside the network, that doesn't matter. But the sender has what? This sender has, say, for example, it has got 10 packets. 10 packets which needs to be sent to the receiver. Fine. Now, how this communication can happen? Through what ways these packets can be sent? Either through TCP or UDP. We'll assume now we are following TCP. So TCP is a form of communication with which we are going to send now. Now we can go for protocols. Transmission Control Protocol. What do you mean by protocol? Protocol is a set of rules. It is a set of regulations. You go to office, you go in a certain dressing code, that's a protocol. You go to college, you follow a certain protocol. So now, in case if I am sending all these packets via TCP, how will I send? The first protocol which I'll follow is this. First, I'll check if my recipient is available or not. That is the first protocol. So TCP will always do this. So after explaining this, TCP, what happens? The first protocol is this. We'll always check if the recipient is available or not. Available or not. That is why it is called as connection-oriented protocol. It will check if the recipient is available. In case if he says yes, this person is asking here, are you available? I need to send you some packets. In case if he says yes, only then he will start sending all the packets. This is protocol number 1. Fine. Protocol number 2. He has accepted the communication. Now what happens? This computer is sending the first packet. First packet. And what TCP will do? TCP will check with the recipient. Hey, I have sent you the first packet. Have you received this packet? TCP will always expect an acknowledgement. It will say, yes, yes, I have received this packet. Thank you. That is an acknowledgement. I'll send packet number 2. And I'll ask, have you received? This computer will say, yes, I have received. That's an acknowledgement. I'm sending the third packet. There is no acknowledgement. What will I do? I'll resend the packets. I'll resend the packet again. I'll resend the packet again. I'll resend. I'll resend till I get an acknowledgement. Now, why do I expect an acknowledgement from the recipient? Why? Just to check, just to verify that whether the recipient has received the packet or not. This is the second protocol of TCP. TCP will always expect an acknowledgement from the recipient. And that is why it is called as heavy-weighted protocol. Why heavy-weighted protocol? Heavy-weighted protocol because this computer sending me an acknowledgement that also comes in a packet. This also comes in a packet. So all these acknowledgement packets will be received to me in the form of packets. If I'm sending 10 packets, if I'm sending 10 packets to this computer, probably I'll be receiving what? I'll be receiving 10 packets as acknowledgement from this computer. So I'll be receiving 10 packets. That is why it's called as heavy-weighted protocol. Just for a normal communication. For normal communication of this, what did I say? When I tried to type google.com, Google page opens, and how many packets were exchanged between my computer and Google? 300 plus packets. Out of which, in case if it is TCP, I send a packet. This is packet number 1, and this is packet number 2, which is received as an acknowledgement. So this is an acknowledgement packet. So if you send 1 lakh packets in TCP, how many packets will you receive as acknowledgement? Again, 1 lakh packets. So that is why it is called as heavy-weighted protocol. And for this reason, it will always expect an acknowledgement. For this reason, what happens is there is no data loss. In TCP, there will be no data loss. Why? Because for every packet it receives, it expects an acknowledgement, and it will check if the packet has been delivered or not. So there is no data loss, but it will be slow. Obviously, it will be slow. Why? Because every time it needs to check. Say you're around like 50 members here. And this is like a TCP communication. Why? I'm able to see your face. If you're not listening, if you're playing with your mobile, I'll say, please listen here. Did you understand? I'm expecting an acknowledgement. But online session, the participants, the 300, 400 participants who are online, they are like what? UDP. They are like UDP. I'll tell you the reason why. So example of this is any normal browser-based communication. It follows TCP. Now, the same 10 packets, let us assume we need to send it via UDP. Yes, send it via UDP. Now, let us go here. Same 10 packets. This time, the communication goes in the form of UDP. Sender. This is receiver. And 10 packets. Now, what happens? TCP is, UDP is first tool. UDP will not check if the recipient is available or not. It doesn't mind you are available, you are busy. No, not like that. It will not check if the recipient is available or not. It will just throw all the 10 packets and it will leave. So UDP's first protocol is this, where it will not check if the recipient is available or not. And that is the reason it is called as connectionless protocol. Connectionless protocol. And will not expect an acknowledgement from the recipient. That is why it's called as light-weighted protocol. Why? Because I don't get any acknowledgement packets. That is why it's called as light-weighted protocol. And data loss will occur. It can occur, but it will be fast. UDP will be faster communication. Even if it is a 10 packet loss for us, UDP works on that basis. But still, why we prefer UDP? It's faster, but can you tell any example why we rely on UDP? Live streaming. Zoom is an example of UDP. we need to address a larger participants. So what we did, we are working, we are discussing via Zoom. So Zoom is an example of UDP. There might be voice lag for some participants, video lag for some participants. For some participants, my screen will be frozen, but we can't help that. UDP is much faster communication. So example of this is, say, for example, WhatsApp call. You make a WhatsApp video call or a voice call, that is UDP. In between, your call gets stuck. There will be data loss, but the data will not be resent again. We will have to ask for the data or any sort of video calls or VoIP calls. What do you mean VoIP calls? Voice over IP. Example of voice over IP. What is VoIP calls? Practical example of voice over IP is this: using Skype to call a mobile. Understand this? From your system, you're using Skype and you're not calling to, this is a mobile. You're not calling to the Skype application in this mobile. No, you're not doing that. Instead, you're calling to this mobile number. How does it happen? That is VoIP. From this app, you're dialing a number and that call gets received to this mobile number. That's VoIP call. And Zoom meetings. All these which require faster communication, they all follow what? They all follow UDP. So this is TCP and UDP. Next time, please, if someone is asking you interview question, in case if I'm sitting in an interview panel and I wanted to test your networking knowledge, first question will be this: what is TCP and what is UDP? I'll for sure ask this. I'll say, think of me as a layman who has basic knowledge of computers, but how will you explain TCP to me? If you say it is a connection-oriented protocol, I'll ask you what is connection-oriented. If you say it is a stateful, this protocol, no data loss, I'll ask you what is data loss. So you have to give them an answer where he will not be able to ask you questions from your answer. So your answers has to be in plain text. Romba clean and the chapna, he will never ask you what is that. So this is TCP and UDP, right? And this TCP, UDP, this packet-based communication, we will for sure be discussing in a lot of different things. I'll tell you why. Understanding TCP and UDP is essential for network security. Why is because, say, you're logging into a website. This is a web server. You're trying to log into this website. So you get this username and password field and your login button. So you enter your username and password. You enter your username and password and you click on login and say, assuming there are like 10 packets going out of your computer. Yes. And like in these 10 packets, probably you'll have the username and password what you have entered. Correct? Your username and password should be here. Your username should be here. Your password should be here. For some websites, it will be in plain text. Plain text. For some websites, it will be encoded. That's fine. But your username and password will be in any of these 10 packets what you have sent. Now, in hacking, in cyber security, we have a concept called network sniffing. Network sniffing. You should have heard this term. Somebody has hacked my password. Somebody has stolen my password. In case, if an attacker, if he is in your network, what do you mean your network? You are all connected to the same Wi-Fi. Your computer is also connected to this Wi-Fi. Your computer, this attacker's computer is also connected to the same Wi-Fi. Just like what you have configured in Packet Tracer yesterday. You are connected to the same network. What do you mean by network sniffing? Network sniffing is where an attacker is using any software to sniff all the packets. To sniff all your packets, he is going to grab all your packets and he is going to analyze all these packets and he is going to find the username and password what you have typed. That is why we will say like security advises you not to join free Wi-Fi and share any sensitive information. Coffee shops, airports, railway stations. You join any free Wi-Fi and you start browsing, give your usernames and passwords. Anyone like this can sniff your usernames and passwords. While we go for cyber security, network security, I will tell how this attack happens. and what tool we can use and how he is going to grab your username and password. For that, we need to understand computer communication happens in the form of packets. You send an image, the image goes in all these packets. You send a music audio file, that goes in different packets. Whatever goes out of your computer, that goes in the form of packets. This is the base for all communication. So in case if I want to attack you, in case if I want to see which website you are accessing, probably I will not disturb your computer. Yours might be iOS, yours might be Windows, yours might be Linux. I'm not concerned about that. When the packet comes out of your computer, I can grab all these packets and I can analyze these packets to find out what is the content of all these packets. As simple as it is. You got this? And next one is, we'll see about TCP flags. Generally, what do you mean by flags? What do you mean by flag? Flag, Nana. In general English, what do you mean by flag? Kodi. Flag is used to speed up. Generally, it's a flag, Indian flag, Pakistan flag. We have different flags for identification. Used to speed up the communication process. Communication process by identifying the purpose of the packet. You want to identify the purpose of the packet? Yes, we can use flags. I'll tell you what happens with flags. And I hope yesterday, Samta should have discussed you about this, the LAN architecture. From your computer, the wire, it goes to which device? Switch, perfect. From switch, router, great. And from router to your WAN, perfect. Now, I am the user who is sitting here. And in my browser, I don't have one tab to be opened, minimum of 10 tabs. I showed you if I open google.com, I get 300 packets, assuming how many tabs you have opened, how many websites you are accessing. Say 8 lakh packets, 8 lakh packets from one single computer. From all other computers, there are millions and millions of packets just in one LAN. Now, assume this, you are a person who is sitting inside the switch. What is your job? Your job is packet forwarding. The main function of a switch is packet forwarding. It will forward the packet based on different algorithms. So packet forwarding, any packet which you receive, you will first check whether it has to go up to the router or it is a communication to this device or to this device. So you'll just forward the packets. That is the main function of a switch. And when you're here, of all these 8 lakh packets, every packet, in case you want to open this packet, read the content, and then identify the purpose of the packet, that is going to take some time. Just like this, I'll give you a non-technical example where in this table, you have like 100 letters, postcards. And I'm asking you, segregate these postcards based on area. Now, if you read the entire address, okay, from address, this, to address, this, okay, this goes to Coimbatore, okay, this belongs to Coimbatore. That is a lengthier process. But the shorter process is reading the pin code. Yes. If you look at the pin code, you can segregate all these postal cards very simply. Like that, instead of reading the entire content of the packet and to understand the purpose of this packet, instead of that, what we do is we place a flag in front of all these packets. If this flag, just for an example, if this flag is Indian flag, you'll easily identify, okay, this packet is from India. US. Likewise, we'll keep a flag in all these packets and we'll write something here so that devices like these, they don't have to spend time looking at the purpose of the packet. Just by looking at the flag. In all these courier packets, have you seen this? They would have written fragile item. Fragile, what does it mean? There is glass inside. They would have written urgent. What does it mean? This courier is urgent. Just by looking at the identification marks like this, we are able to identify the purpose of the packet. Likewise, we have flags here. So what kind of identification marks we can make? We have many different flags, but I'll say SYN, reset, SYN, acknowledge, reset, and fin. This is enough. So we have synchronize flag. This is acknowledge flag. This is reset flag. And this is finish. Yes. Yes. I'll tell you. See this. This computer is a sender and this is a receiver, to recall what we have discussed in the beginning for TCP. And in TCP, I have 10 packets is the first example which I showed you. Now this computer wants to check if the recipient is available or not. How will it check? It will send a packet. Inside there will be no data. No data inside this. But I'll set a flag here and this flag will be marked as synchronized flag. The recipient, once it receives a packet, it doesn't have to open the packet and check the contents of the packet. Just by looking at this information, it is like receiving a friend request in Facebook. If you confirm, you can start chatting with that person. If you don't want, you can decline the friend request. So if any computer or if you receive a SYN packet, what does it mean? Somebody has sent you a connection request and they wanted to communicate with you. As simple as it is. So in case if it is okay, if this computer is okay, it will send an acknowledgement. If it is not okay, if this computer is busy and it doesn't want to speak to you, it will send a reset. Yes. And after you have completed sending all your packets, you will send an empty packet with a flag called finish, and this computer indirectly understands the communication is over. So it is a form of, it's a labeling kind of technique where it is easy for the devices to understand the purpose of the packet. As simple as it is. Now, I told you this is a connection request. See, every topic, networking has a lot of different topics. But the topics what we have chosen for you guys is something which is related to security. I told you TCP, UDP, obviously you go till forensics, you will be recurring the basics of TCP and UDP. Point number one. Point number two, we have discussed about flags. Now, how flags will be related to security. I'll give you this small example scenario where what we are trying to do here is this connection request. Now, what happens if I give unmute option to everyone? Unmute option to all the participants in Zoom. What will happen now? Everybody will come up with one sort of question. Yes, they'll shoot a lot of different questions. These are like connection requests for me. I'm the server. I'm the server here. And in Zoom, I get a lot of requests. And these requests are like connection requests, SYN packet. Now, what happens to me? I don't know what to do. Now, my service will be stopped. I'll start answering this person and this person starts speaking. It will be a whole mess. Yes. Likewise, we'll consider an example of IRCTC website. I hope you all know IRCTC website. Train ticket booking website. Normally, when you access this website, what happens? This website opens, when you type irctc.co.in, the website opens in 0.2 seconds. That is a normal response time. But 11 o'clock, 11 a.m., Tatkal booking timing. When you try accessing this website might respond to you in like 2 seconds, 5 seconds. There will be a delay. Why? Because we have so many requests going to the server. So the server's load handling capacity might go down and it might delay in responding to the clients. Same happens with Flipkart, Amazon, during Big Billion sale, different kinds of sale, the app will be slow. Why? So many requests. Now, what we can do is, I'll tell you how a DOS attack is done. In security, I'll show you in detail how this is done. But in general, if this is my server called xyz.com, this is my server and I am performing a DOS attack on the server. Now, what I'll do is, I'll use this tool called X. I don't want to name this tool, X. And this X, I'll say the target is xyz.com. And I'll say, okay, send SYN packets, means connection request packets. And in like 1 minute, send how many packets? I'll say send 10 lakh packets, 1 million packets. So this tool, what it does, it will send within 1 minute, it will send 1 lakh packets. Now what happens to this server? The server's response will slow down for whom? For a genuine user who is trying to access this server Usually the server will respond in 0.2 seconds. But since we have done this, the server is going to respond slowly to the server. Say, for example, 2 seconds. Now, as an attacker, what we have done, we have performed a DOS attack on this server. And the name of this attack is called SYN-FLOOD attack. Yes, it's called SYN-FLOOD attack. Yes, it is DOS attack, but a specific category of attack which is called a SYN-FLOOD attack. Now, instead of SYN, if I chose acknowledge, that is called acknowledge flood attack. Or if I chose reset, that is reset flood attack. I can send any number of packet to a particular server to load the server, to overload the server, so that it responds slowly to other genuine clients. I'll show you something like this where okay. Look. So if you look at this, not this. Where is that? Okay, yes, yes, this. So if you understand the little basics of what is happening in the background, technically, larger attacks will be very simple for you. When you look at this, there is some tool which is performing a DOS attack. And if you look at this, we have UDP flood attack, TCP SYN flood attack. Yes, all you have to choose is a number and you can go with any type of attack. But basically what is happening in the background is this particular tool is going to send a lot of packets based on your request to the server, and it is going to slow down the server. You got this? So this is about the basics of what TCP and TCP flags are. I'll later we'll discuss about TCP port numbers and TCP three-way handshake. And before that, Samita will continue with the routing protocols, what we were discussing yesterday. And probably tomorrow or day after tomorrow, we'll continue with the remaining topics and then move on to network security. Yes. And my name is Shankara Subramanian. And thank you.
Good evening, guys. I am sharing the attendance form link with you now in the Zoom chat box. Please do fill in this. Fill in the attendance and come back for class. Yes. Okay, so a quick recap of what we saw yesterday. We discussed about IP address, right? So we learned about the classes of IP and then the subnet mask. Yes, after that, what did we see? Private and public IP address. Private and public IP. Yes, and then we did one LAN without internet. And I also gave you a to-do to work with the Wi-Fi modem. I hope you have worked on it. Yes, and I hope the attendance link opened for everyone. Yes, great. Okay. All right. So coming back to this IP topic, we were supposed to discuss one more thing yesterday. Talking about IP, we have NID, default gateway, and BID. NID, DG, and BG. Okay, there are three things in IP address. NID stands for network ID, and DG stands for default gateway, and BID stands for broadcast ID. Okay, all these three are IP addresses only. All these three are IP, but you cannot assign this IP to any computer. You can't assign this IP to any computer. Then what is the purpose of having these three IP, NID, default gateway, and broadcast ID? Now, when you take a network collectively, a network will have many devices inside. And each device will have its own IP address. Yes. And what is that IP called? What is the name of the IP which gets assigned to a computer? It is called private IP. Very good. So each device will have its own IP addresses, right? Now for this entire network, there will be an IP, and that IP is called the NID, network ID. So network ID is like an identity to your entire network. You can't assign it to a computer, but it is like an identity to an entire network. Similarly, there is another IP for this entire network that is called broadcast ID, BID. Okay. First, let me give you an example for network ID. Now, network ID is something like a department name. Now, let's say there is a department called computer science. And under computer science, you're going to have first years, second years, third years. And under each year, you're going to have different sections. And under each section, you're going to have different students with different names, right? But collectively, what do you call these students? You call them as computer science students. That is the case with network ID. So you can have any IP to computers inside a network, but collectively, this entire network will have an IP, and that IP is called network ID. Okay. And then coming to broadcast ID. Now, have you all come across this feature called broadcast messages in WhatsApp? Yes. So in WhatsApp, what you can do is you can create a broadcast group, and you can add up to 256 participants inside, right? So you can add 256 participants in this broadcast group. And when you send a message in this group, it will get delivered to everyone individually. Correct? It will go to their private chats. It will not be like a normal group chat. Yes. Similarly, inside a network, when you have like 50 computers and you wanted to share something equally to all the 50 computers, then you don't have to go choose the private IP individually. You can send it over the broadcast ID, and it will equally share it to all the computers inside the network. Okay. And then default gateway. Now, what is default gateway? Again, it is an IP which you normally assign to a router. Yes, so router will also have an IP address, and that IP address is called default gateway. Okay. Now, how do you find these three IPs? Network ID, broadcast ID, and default gateway. How do you find these IPs? Now, remember this. NID, network ID, it is the first IP in a range. And then DG, default gateway, it is the second IP in a range. And then BID, it is the last IP in a range. First IP, second IP, and then last IP. All right. Now, when you see an IP address, you know two things to find out from an IP. What are they? Class and then subnet mask. Very good. So when you see an IP address, you know two things, that is class and subnet mask. Now, when you find out the class and subnet mask, based on these two, you can find the NID, default gateway, and the broadcast ID. Okay, let's see how to do that. Now, we'll take one IP address. I'll take this IP, 192.168.1.10. Yes, which class of IP is this? Very good. Class C. Super. Now, for class C, what is the subnet mask? How many network and how many host? Very good. 3 networks and 1 host. Okay. Now, based on these two, let's find the NID first. Okay. Now, see here, NID, it is the first IP in a range. It's stated as first IP. Now, what is the range of this IP? 192.168.1.10, right? What is the range of this IP? Huh? What is the, okay, 0 to 255 is the entire range. Here, which number is it starting with? 192. So 192 is our range. Yes. For 192, what is the first IP? Very good. 192.0.0.0. This is the first IP of this particular number, right? What is given here? Here, NID is the first IP in a range. What you have to keep in mind is, although this is the first IP, you should always make sure you are not changing the network portion. You will only change the host portion. For this IP, the first three numbers are network portions, right? Only the last portion is the host portion. So you will keep the first three numbers as such. 192.168.1, and you will only change the last number. Okay. And another hint, network ID will always end with 0. So keep in mind, NID is an IP that always ends with 0. That is the first IP. Now coming to default gateway. Now default gateway, it is the .1.1. That is the next IP. If this is the first IP, this becomes the second IP, right? Now for 192, what is the last IP of this range? Very good. 255.255.255, right? So broadcast ID, again, you're going to keep the network portion same, 192.168.1, and you will change the last value alone to 255. This is how you find NID, BID, and default gateway. Now, let me give you another number. You all find out with that. 130.6.8.15. Okay, now give me answers. What is the class of this IP? This is class B. Yes. And for class B, how many network and how many hosts? 2 networks and 2 host portions. Now, based on this, give me the NID for this IP. 130.6. You will keep the network portion as such and you will change all the host portion. So what will be the IP? 0.0. Very good. What is the default gateway? 130.6.0.1. That is the next IP. And then what would be the broadcast ID? 130.6.255.255. This would be the last IP. This is how you find NID, default gateway, and broadcast ID for any IP address. Got it? Yes. Okay. Now with this, let's move into the router topic. So yesterday we started with routers. I just gave you an introduction of what is router, and I also showed you a picture of a router, and I also told you about the ports. Yes, we discussed about the ports. How many ports does a router have? 4 types. Yes, we have interface port, fast Ethernet, gigabit interface, and then serial interface. Right. Now, remember one thing. Whenever you use a router, obviously you're going to connect this router to at least 1 or 2 of its interfaces. Okay, this is called the port. Another name for this port is interface. Okay, so whenever you use an interface in a router, you have to assign IP. Whenever you use an interface in a router, you have to assign IP, and that IP should always be the default gateway. It has to be the default gateway. So whenever you use an interface in an in a router, you have to assign an IP. Only when you assign IP to interface, the interface will get a meaning. It will become active. If not, the interface will not get active. Okay. Now to assign IP to this interface, there are 2 rules which you have to follow. All right. So now let's assume we'll take a router and now tell me, we have 1 router on the screen. Yes. And how many interfaces are used? 4. Very good. All these interfaces are nothing but the connection points. Yes. Now, how many IPs should you assign? 4. Yes. So if you've used 4 interfaces, you have to assign 4 IP. Okay. Now, for this first interface, for this interface, I'll assign an IP 192.168.1.1. Okay. For router, you have to assign default gateway only. So I've given this IP, very random IP. Yes, you can use any series. Like in 192.168, you can use any number you want. Now I've just taken from 1. Okay. Now for a router, in one interface, if you use one series, you cannot repeat it for the next interface. So for the next interface, when you give IP, it should not repeat in one series. So you have to use another series. So let's give 192.168.2. And for the next, you can't repeat both 1 and 2. So let's write 192.168.3.1. And for the next, you have to again give another series, that is 4.1. Okay. So rule number 1 for assigning routers, IP to a router is all interface of a router should be in different network, or it should have different network ID. This is the first rule. Now here, if you see, for all these IP, now this 1.1 is the default gateway. What would be the network ID? 1.0. For this, 2.0. For this, 3.0. For this, 4.0. So a router's interface should always be in different network. Now this means it is in a different network. Each interface is in a different network. Now let's connect another router to all the other ends. Okay. Now I've connected router to another end. Okay. Now this interface 1.1 is connecting to this interface in the next router, right? Now for this interface, the IP you should give should fall under the same series. Okay. So if here you've used 1, here also you have to use 1 only. So I'll use 192.168.1.2. Now here you've used 2. So what should you use here? 2 series. So 192.168.2.2. Now here if you've used 3, what you should use here? Again 3 series, that is 192.168.3.2. And here if you've used 4, you have to use 4 here again, 192.168.4.2. So the rule number 2 is a serial interface connecting 2 routers should be in same network. Now here if you see, this is also 2.0, this is also 2.0. Here it is 1.0, 1.0. Here it is both 4.0 and here it is both 3.0. This is how you assign IP to routers interface. Okay, so when you look at all the interfaces in one single router, it should be in different network, 1, 2, 3, 4. Okay, but then when you see 2 routers getting connected, they both have to be in the same network. I'll give you another example which you will be doing it for your to-do today. Okay, so we'll take router 1, router 2, and router 3. Now, for this computer, okay, let's say this is router A, this is router B, and this is router C. All right. Now tell me how many interface does router A have? 2. Here and here we have 2. How many interface router B has? 1, 2, and 3. How many interface router C has? 1 and 2. All right. So now I'll start from here. For this, I'm going to give an IP 192.168.1.1 for this interface. Okay. Now here, if I use 1, what should I use here? I should use a different network, right? So I will use 2. 192.168.2.1. Now here, if it is 2, what should you use here? You have to use 2 because it is connecting 2 routers, right? So here you will use 192.168.2.2. Now here we have used 1, 2 already. Now here what you can use 3 series. 192.168.3.1. And here 4 series. 192.168.4.1. Now here if it is 4, here also it is 4. So 192.168.4.2 and here we'll use 5. 192.168.5.1. Now if you see, both the rules are applied. For one router, when in its interface, it has different networks. But when two routers are connected, they have same network. Okay. I'll also type the router rules for your reference. So rule number 1, all interface of a router should be in different network. And rule number 2, serial interface connecting two routers should be in same network. So when you're assigning IP, you have to keep these 2 rules in mind. Okay. Now that you have assigned IP to all the interfaces, do you think these 2 routers can communicate? No. You have just assigned IP. That's it. You have assigned an IP just to make sure that interface has a meaning, becomes active. That's it. Now, if you want this A router and B router to communicate, you have to perform something called routing. And here also, if B and C has to communicate, you have to perform something called routing. Right? Now, what is routing? Routing is a process of making 2 routers communicate with each other. There's a process of making 2 routers communicate with each other. All right. And how is that going to do? Now, yesterday, when I told you about routers, I said router has a memory. Yes. What is that memory called? I told you router has a memory, right? What is that memory called? MAC table? MAC table is for switch. Router has a memory. What is that memory called? I said router has a memory and that memory is called IP table. Okay. Router has a memory and that memory is called IP table. So router will store IP address. Now what IP address it is going to store? It is going to fill this IP table with network ID. This is where NID comes into picture. Okay. So in router, we have this memory called IP table, and inside that IP table, we are going to fill the network IDs, and that is how you're going to achieve routing. Okay. So routing is a process of making 2 routers communicate with each other. How? It is achieved by filling the IP table with either known or unknown network ID. Known or unknown network ID. All right. So first, let me tell you how to find known network IDs for each router. Now tell me, take this entire setup. Okay, we have 3 routers here, right? Tell me what network IDs are occurring in these 3 routers. What are the network IDs that occur in these 3 routers? Just go from beginning and tell me the network IDs. We have 1 series. So we have 1.0. Yes, and then 2.0 and then 3.0. Good. And then 4.0 and then 5.0. So these are the network IDs which we have used in these 3 routers, right? Now, for each router, let's write down the known network ID. For each router, we are going to write down the known network ID. Okay. Now, how do you find the known network ID? Now, router A has how many interfaces? 2. In that 2 interface, what are the network IDs present? 1.0 and 2.0. That is the known network ID for router A. Router B has how many interfaces? 3. And what are the network IDs present? 2.0, 3.0, 4.0. These are the known network IDs. For router C, how many interface? 2. 4.0, 5.0. These are the known network IDs for each router. Okay, this is how you find known network ID for each router. Now, how do you find unknown? Now, you have 5 network IDs. In this, 1 and 2 has become known network ID. What are remaining here? 3, 4, 5. So, for router A, 3, 4 and 5 are unknown network IDs. For router B, 2, 3, 4 are known. What is remaining? 1 and 5. So, 1 and 5 becomes unknown. And for router C, 4 and 5 are known network IDs. So, what are remaining? 1, 2 and 3. These are called the unknown network IDs. This is how you identify known and unknown for each router. Okay. So inside router, you have something called IP table. And inside that IP table, you have to fill either known or unknown. You can't fill both. You're going to fill either known network ID or unknown network ID. You will use any one. For that, first you should know what are the routing types. So in routing, there are 2 types of routing. Number 1, static routing. And number 2, dynamic routing. Okay, all these are, the objective of all these routing is same. The objective of all these routing is to make these 2 routers communicate with each other. All right, just that we have different types. Okay. Now, static, there is only one configuration, and in dynamic, you have something called RAP, OSPF, and EIGRP. There are 3 types of dynamic routing. Now, we are not going to discuss about both these 2 now. Why? Because we handled networking pre-training earlier, and we have already discussed RAP, OSPF, and EIGRP earlier in that pre-class, and that routing concept is already uploaded in our YouTube channel. So if you go to Prompt Infotech channel, you will find static routing and dynamic routing videos. So free time, you go there and you watch that channel, and you can practice all these routing. What we are going to see now is something new, that is BGP. Okay, this is a type of dynamic routing. This is a type of dynamic routing. Apart from RAP, OSPF, and EIGRP, there is another type of routing that is called BGP. This you can't find video, so that is why we are taking this now. All right. So now to configure this BGP routing, to configure this routing, what all you need is, you need known network ID. That you know how to find out, known network ID, right? And second thing, you need something called autonomous number. Autonomous number is nothing but a number that comes from any range between 0 to 65, 535. Any number between, any number between this range, and it is different for all routers. Remember, when you use one number for one router, for the next router, you have to use a different number with BGP alone. All right. And third thing that you will need is the neighbor IP. With these 3 things, you can configure BGP. All right. Now let's go to packet tracer first. Now, what we are going to see in packet tracer is, let's take just 2 routers alone. We'll take 2 routers. For this router, the IP is going to be, for this computer, the IP is going to be 1.10. For this computer, the IP is going to be, okay, before that, we'll give IP here. For this, it is going to be 192.168.1.1. This 192.168.2.1. This will be 192.168.2.2. This will be 192.168.3.1. And this will be 3.10. Okay, so based on the default gateway 3 series, you have to assign IP in the same series for computer. Okay, so we are going to create this setup now in Packet Tracer. All right, and we'll find out how to assign IP to routers. So once the Packet Tracer is open, guest login, close. It's confirmed. Now let's assume this is going to be TN router and this is going to be Kerala router. Two different routers. Okay. So for each router, you have to set an autonomous number. So for this router, let me set autonomous number as 100. And for this, I'll set autonomous number as 200. Two routers with two different autonomous numbers. Now tell me, for TN router, what are the known network IDs? Known network IDs of TN router? 1.0, 2.0. Very good. And for Kerala router, what are the known network IDs? 2.0 and 3.0. These are the known network IDs. I'll tell you what is neighbor also. I said something about neighbor, right? Now, look at TN router. Now, for TN router, the only neighbor the TN has is Kerala router. Correct? And in Kerala router, how many interfaces do you have? 2. In that 2 interface, what are the IPs present? 2.2, 2.2 and 3.1. These two are the neighbors for TN router. For Kerala router, TN router is the neighbor, correct? And how many interface TN has? 2.2, that is 2.1 and 1.1. What we are saying is, see, TN router, your neighbor is Kerala. Okay. And to enter into the Kerala router, you have 2 routes. One is this and one is this. So keep this as your neighbor. And similarly to Kerala router, we are saying, see Kerala router, your neighbor is TN, and to enter into TN, you have 2 routes, that is 2.1 and 1.1. So we're just saying both the routers that you two are neighbors, and in order to communicate, these are the routes inside which you have to communicate, right? Now first, let's open Packet Tracer. Still not open, confirm guest. Okay. Okay. Now in Packet Tracer, let me take 2 routers. The size is visible, right? Okay. One router and then we'll take another router. Yes, we have 2 routers in Packet Tracer now, and then we'll take 2 switches. And then we'll take 2 computers. All right. Now to connect computer with the switch, you need copper straight through cable. So we'll choose fast Ethernet, and in switch, you can choose any port you want. Again, from here, fast Ethernet, and switch, you choose any port you want. Okay. Now in router, to connect a switch and a router, you will use fast Ethernet. To connect 2 routers, what interface you will use? Serial. Very good. So you will use serial, right? Now let's see whether we have serial interface in this router. To find out if you have serial interface in this router, just open the router and go to config. In router, go to config. In config, in the left-hand side, you have to see whether you have serial interface. Do you have? No, you don't have it. In Packet Tracer, only in few routers, you will have serial interface. In few routers, you will not have serial interface. So if you don't have serial interface, follow this. Just go to physical. Okay. And then physical, when you zoom in, this is the backside port of the router. Okay. So what you will do is, this is the switch. Just go click on the switch and it will turn off. Once the router is off, click this WIC2T option. Just click, drag it and bring it here. And then again, turn on the router. Okay. You have to open the router, go to physical and zoom in, turn off the router, click on WIC2T, drag it, bring it here and then turn on. Off, click and drag, on. Just 3 steps. Okay. Now, if I open the first router and go to config, see, I have serial interface here. We got our serial interface. Yes. Now let's start connecting. So I'll again choose copper straight through cable. I'll click on switch, and in router, I'm going to choose fast Ethernet. And then again, I'll select copper straight through. I will click on switch. I will go to this router and choose fast Ethernet. Now to connect router and router, in cable, you find this red color cable here. You have two cables, serial DCE and serial DTE, red color cable. Okay, you'll choose that. Click that cable and click on the first router, select serial, and click on the second router, select serial. This is how you connect. Okay. Yes, this is how you connect the devices. Now, once you connect the device, next step is to assign IP address. Okay. So now we'll start assigning IP. Now to start assigning IP, let's start from router A, first router. So in router A, we have used two interfaces. One is fast Ethernet and another one is serial. So what IP I should assign? For fast Ethernet, I should assign 1.1. And for serial, I have to assign 2.1. Yes. So we'll open router. Okay. And in router, first I will open the fast Ethernet interface. In config, just go click on fast Ethernet. So I'll click on fast Ethernet. And here see it is asking for IP address. Yes. We'll type IP 192.168.1.1 and then the subnet mask. And then at the top, you have this on button. Click on the on button. So only then that interface will become active. Yes, this is with fast. And then go with the serial. So serial will assign 192.168.2.1 subnet mask and turn on the interface. That's it. So we have assigned IP for both these interfaces, 1.1 and 2.1. Similarly, we are going to assign IP for these two interfaces in Kerala router. So again, open the second router. Go to config, choose serial, and for serial, the IP is 192.168.2.2, subnet mask, turn on. Then choose fast Ethernet, give IP 192.168.3.1, subnet mask, turn. That's it. Now you have assigned IPs for all the four interfaces in both the routers. Next step, go to computer. Go to computer. Now I've opened the first computer. And in computer, go to desktop, IP configuration. Let's assign IP for computer. So what IP should be assigned for computer? 1.10. So I'll assign 192.168.1.10 subnet mask. And next line, you have to assign the default gateway. Now for this computer, this 1.1 is the default gateway. Right? So you'll assign 192.168.1.1. That's it. Close. Now go to the second computer. Second computer, go to desktop, go to IP configuration. So for second computer, what IP you should assign? 3.10, right? So we'll assign IP address 192.168.3.10 subnet mask. And for the second computer, the default gateway is 3.1. So you'll assign IP 192.168.3.1 and close. Now, what we have done is we've just given IP to all the devices, right? Now, if you want this computer, first computer and second computer to communicate, these two routers has to communicate first. For that, you have to do BGP. Okay. Now, for BGP routing, we are going to do this routing through command line, through CLI. Okay, you're going to do it through CLI. So how do you do that? First, you have to, I'll show you where you have to enter, but first I'll give you the commands. So first, when you enter inside the command line of a router, this is the first thing that you see. Router and then angular bracket. This is where you have to log into the router. So to log into the router, you have to type this key called enable. This is the command to log into a router. Once you type this, it will change to router hash. Now from route, this is called privilege mode. From here, you have to go to the configuration mode. So you just have to type this command conf t. So once you type conf t, you will enter into this config mode. Okay, so this is login mode, this is privilege mode, and this is configuration mode. This is where we are going to configure BGP. Now, where do you find this? Go to packet tracer, click on this router, first router. I've clicked on the first router, and in first router, next to config, see here, you have this option called CLI. Click on CLI and just click enter. Now, when you click enter, it is showing something like this config-if, no? Now, it has to be something like this, router and angular bracket. To get that, just type exit, exit, exit. And see, we are in the login mode now. Okay, so you'll go to the login mode. And from here, you're going to log into the router. Then you'll enter into the configuration terminal mode. All right. So once you enter into this configuration terminal mode, what you're going to do, as I told you, for BGP routing, you need three things. One is known network ID. Second one is the autonomous number. And third one is the neighbor IP, right? So how do you type this? Let me type the commands here. First, you will type router, BGP, and you will set the autonomous number and click enter. Okay. Here, first you will log in, enable, and then you go to conf t. You are inside the configuration terminal mode. Now you will type router, BGP, 100. Okay. Now the command changes to something like this, config-router. Now here, what you should do, you have to add both your network IDs. Now for router A, what are the two known network IDs? 1.0 and 2.0. Let's type that. You have to type network 192.168.1.0 and hit enter. And then again, you have to type network 192.168.2.0. Okay. See, I'll type here. I'll type network 192.168.1.0 and again network 192.168.2.0. Okay, so we've added autonomous number and we have added two known network IDs, right? Next step, you have to add the neighbor. Okay, so to add neighbor, you will type neighbor, and for TN router, what are the neighbor IP addresses? 2.2 and 3.1. Yes. So you will add something like this. Neighbor 192.168.2.2 remote -as, and you have to give the autonomous number of Kerala router because this belongs to Kerala, right? So Kerala router autonomous number is 200. Again, you will type neighbor 192.168.3.1 remote -as 200. Let's type the same here again. I'll type neighbor 192.168.2.2 remote -as 200. And next line, again, neighbor 192.168.3.1 remote -as 200. Enter. That's it. These are the configuration lines which you will write in the first router. Okay, that's it. Now close it. Now go back to packet tracer, choose the second router. In second router, again, you're going to do the same steps. This you will do in TN router. And next you will open Kerala router and you will do the same step. Here what you will do, instead of 100, you will give autonomous number 200. And for known network IDs, you will type 2.0 and 3.0. And for neighbor, you're going to give 2.1 remote -as 100 and 1.1 remote -as 100. Let's type. So I'll go to this router. I'll show it to you again. Now we are in the second router. Second router, you'll go to command line, hit on enter, give exit, 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 enter. Now we are in the login mode. Now type, we'll open the notes and this simultaneously. Okay. So first we will type enable, enter, and then conf t, enter, and then router BGP 200. Yes. And then you will add the network IDs 192.168.2.0 and again network 3.0. Then we'll add neighbor 192.168.2.1 remote hyphen as 100. And click enter. Again type neighbor 192.168.1.1 remote hyphen as 100 and hit enter. That's it. Now we have done BGP routing to both the routers. Now what we have to verify? We have to verify whether these two routers are communicating. We did BGP for that only. How do you verify? From this computer, you have to ping this computer. Okay, so what IP did we give for this computer? 1.10, right? So the output that you verify would be from this computer, ping this computer and it has to reply. And from this computer, you have to ping this computer and it has to reply. So we'll go to the first computer. I'll open command prompt from the first computer and I'll type the IP of the second computer. So ping 192.168.1.3.10 and hit enter. You should get reply. See, you're getting reply. When I ping again, you will get all 4 replies. Okay. Again, from this second computer, let's ping the first computer. Command prompt, ping 192.168.1.10, hit enter and you'll get reply. Okay, so we made 2 routers communicate with each other, and since 2 routers are communicating, these 2 computers are also communicating. Okay, this is BGP. If you wanted to learn about static and dynamic, we already have videos. You can watch that. Okay, now that I have done this in class, this is not your assignment. So your assignment 2 for today. Assignment 2 for today is you're going to do BGP for 3 routers. Okay, so let me draw the setup for you. So in Packet Tracer, you're going to have 3 routers. This is how your Packet Tracer setup is going to be. 3 routers with switches and computers. The first router is going to be the TN router. This router is going to be Kerala router. And this router is going to be Andhra Pradesh router. Okay. And IP here for this computer 1.10. So this is 1.1. This will be 2.1. This will be 2.2. This will be 3.1. This will be 4.1. This will be 4.2. This will be 5.1. And this computer's IP would be 3.10. And this would be 5.10. All right. So you will create a setup like this. You will assign IPs. You will configure BGP for all the routers. And the final output should be, you have to verify from each computer, ping and see, it has to ping. Okay. So the screenshot, how you will take at least one router, one computer pinging with another computer is fine. Just open the command prompt. The setup has to be in the left-hand side and your output in the right-hand side. Like this. Take a screenshot. Just like yesterday, I will share a form link in your channel. Upload that in that form link. This will be the only screenshot. You didn't receive the form link? It is shared in your channel. Are you not in the channel? Networking channel? No? Okay. You can, I'll send you the link. You can join in the channel. Not shared? It's shared. I shared the notes. I shared the channel, form link also. right? So this is going to be your assignment 2, BGP. And okay, let me also help you with this. See, now for TN router, what are the neighbor routers? TN router has 2 neighbor routers. What are they? Kerala and Andhra Pradesh. For Kerala router, it has 2 neighbors. What are they? Tamil Nadu and Andhra Pradesh. And for Andhra Pradesh router, they have 2 neighbors. What are they? Kerala and TN. So you have to add all the neighbor IP addresses. For TN, all the remaining 2.2, 3.1, 4.1, 4.2, 5.1, all these will be neighbor IPs. Only then it will ping. Okay, try it out. And I hope you all have given your attendance with the form link shared. Yes. Let's meet tomorrow, guys. Thank you so much.